All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD1000 Web Development Technologies course, I've been preparing a series of video presentations that are based on the PowerPoint slides for one of the textbooks we're using for the class, and that is Murox, JavaScript, and jQuery. So far, I've done all of Section 1. I started on Section 2, but I've decided to divert. And I did Chapter 12, and now I'm in the middle of Chapter 13. So in the last lecture, I did what you need to know about control structures and the invoice app. So we're going to pick it up here on how to handle exceptions. Now, one thing that I mentioned before is when you work with exceptions, they're exceptions to the rule. So in other words, exceptions in programming are not a good thing. Did you hear me? Exceptions in programming are not a good thing. All right? So one way that you can check, I usually tell people there's three basic ways that you can check for errors. All right? And the first way that you can check for errors is to not check at all. It's what I call the ostrich method. Just like the ostrich tucks its head, and lets the world go, in the sand and lets the world go by him or her. You can just basically not put any error checking in to your code at all and hope that whoever is running your program always knows what they're doing. Well, as you'd probably guess, that's the worst way. The next way is to let bad data into the system. In fact, let's say not even try that. Let's say the next way is to not let bad data into the system at all, and typically use things like if statements. Now, you saw that with some of the stuff that we did earlier. Okay, now we didn't really exactly do that, in here, but for instance, we could have come in here and instead of, what if we did this? What if we had said in here, parse int prompt input a number between 1 and 100. Okay, so we said that, and again, we'll just give it a default value of 50. All right, and then we did the same thing for here. So I'm going to move this over to here. All right, and we've got our max. Fine. But what if we came in here and we said while, so if you screw up on either one of these, so while number 1 is less than 0, or number 1 is greater than 100, so while that, or number 2 is less than 0, or number 2 is greater than 100. So if that's the case, we're just going to ask you to do it all over again. And we would have needed here paren, another paren, another paren, and there we go. This will be a 2. And another paren. So what we're doing in this case right here is if the user puts any bad data or inputs any bad data, they're going to be stuck in that loop until they do what we've asked them to do. So by the time we get here, we know that number 1 will have a number between 1 and 100, and number 2 will have a number between 1 and 100. So that's another way we can check. We don't allow bad data into the system, period. A third way of doing it is to let bad data into the system, but handle it the way we want it to be handled. All right? And you oftentimes do that by using what's called a try-catch block, which can have an optional finally statement in there. So inside of try, inside of those curly braces, you put one or more statements that can conceivably fail. Inside the catch, you let it know what the error was, and what you want to do based on that error. And you can have several catch statements. The finally is not mandatory, but if it's used, it's typically set up to be used for what I like to refer to as housekeeping, closing files, closing databases, whatever. So if the try works, you totally skip the catch, but you do the finally if you have it. If the try fails and you've got a catch that handles it, you handle it, you still do the finally. All right? And when you've got errors, errors have names and errors have messages associated with them. So notice what we've got here. This is that calculate future value program that we had earlier. All right? And basically, this says if I've got anything bad in here, I'm just going to give you what the error was and what the message was. So if for some reason, for example, investment that we passed in or rate that we passed in or years that we passed in, somehow it was an error, all right, it would handle it. And it would just say this. Now this is about as generic as you can get. This will try to catch any kind of error that there is. It says you can even have a catch block with no parameter. I don't typically do that. I always put something in there. All right. You can also throw your own errors. For instance, all right, we talked a little bit earlier, I think we went through this, and we talked about a miles per gallon program. But whether we did or not, imagine that we're asking somebody how many miles they drove, and we're telling them that the number of miles they drove must be between, let's say, 1 and 1,000. And if they put in a number that's less than 1, or they put in a number that's greater than 1,000, it's invalid, right? So we could come up with our own error message, our own error, that would say, hey, you put in an invalid value. It must be a number between 1 and 1,000. And if they did something wrong, we could throw that particular type of error. All right, so here's an example. Notice this is better than the other one because at least you're letting the user know what they did wrong. All right, so there was an investment problem, there was an error problem. Now, what if they had a problem with years? All right, we really should have checked that too because years should not be less than or equal to 0, and maybe you've got a maximum, maybe 25. So again, this try, if this works, you skip this, but you do this. If this try fails, you do this, and then you do this. I can't put it any better, I guess, than that. There are built-in errors in the error hierarchy. Notice there's a range. So again, we could set something like that up. A reference error where you're trying to work with a variable you haven't defined yet. Some kind of a syntax error, which really shouldn't happen. And some kind of a type error where you're working with a data type that you're expecting to be one thing and it's something else. So 3 reasons, as it says there, for using a throw statement. Number 1, well, if you've got a try catch and you want to make sure that it's being hit, you can test it by that. Number 2, to throw an error from a function that lets the calling code know what the problem was. And again, and 3rd, to perform some processing after catching an error. So what if you catch the error and you have them try it again and it's still bad? Type of an idea. So this is most of the stuff that's related then to exception handling. Try catch, exception, and again, an exception is an exception to the norm. It's a bad thing. Exception handling, a try block, a catch block, a finally block, throwing your own exception, and the throw statement itself. All right. The last part, I believe, of the chapter talks about regular expressions. I may have gone through this before, but just in case I did not, I'm going to come in here and I'm going to put in, what is it? Is it regular? It's regular expression .info. The word regular immediately followed by the word expression .info. Site's ugly as hell, but it's the best site I've ever found for things. It has tutorials. It covers different languages. So again, if I went to tools and language and I went to JavaScript, using regular expressions with JavaScript. And it basically shows in here what has to be done. And I'm not saying it's going to answer every single question you have, but if nothing else, it'll give you a terrific start. All right. There's different ways, as it says, to do this. So here we're creating a new regular expression object. There'll be an example soon. And here we're doing a literal. So it's whatever comes between these forward slashes. So in both these cases, we're trying to see if something, the pattern is the word Babbage. Okay. And I can do it by creating a new regular expression object or by creating a pattern. Then we can test to see whether or not something is true or false. So again, if we do Charles Babbage and we test that, yeah, it's going to return true. But if we try to test for Babbage, all right, if we try to test for Babbage, which was here, and it's Ada Lovelace, there's no Babbage in there, so it'll return false. All right. Now, one thing about this, you could put flags in here. I means ignore case. So if we did not have this I in there, if it wasn't there, Lovelace from here would return false because it's a capital L. Here it says any of the characters can be upper or lowercase. You can do that either with the regular expression constructor or with the literal. All right. Here are some special characters that you oftentimes can use with regular expressions. \n for the new line, \t for the tab are probably the ones you're going to use most often. And they give you some examples for matching special characters. That's probably not going to be that big of an issue. All right. Next, dot. Any character except a new line and a period unless you use the slash dot. All right. Bracket, bracket, anything inside of the bracket. So if I put in here A-Z in lower and uppercase, it would match any uppercase or lowercase letter. If I put in here a caret, A-Z in upper or lowercase, that would say match anything except an alphabetic character. There again, I already mentioned that. W is any letter, number, or underscore. That's a little w. A big W is anything except a letter, number, or underscore. Little d matches any digit. Big D matches anything that's not a digit. Little s is any white space. White space is defined as a space, a tab, a new line, a carriage return, a form feed, or a vertical tab. Big S is anything but not white space. All right. And there's always several different ways of doing this. There's pattern matching. Now you saw before when we looked at that caret character right here, when it's used in here, it means not. When it's used in a string, it means starts with, this means ends with. So this says must start with Charles. This says must end with Babbage. This says must start with Babbage. So as always, there's a lot of different ways that you can test. You can create subpatterns, which is a pattern within a pattern. Other stuff that you can do, probably the ones you're going to use the most often in here. Well, actually, you could use any of them. N means you have, so if I put a 6 in there, the pattern I had must repeat exactly 6 times. If I say 1, 6, then the pattern must repeat between 1 and 6 times. All right. The question mark says 0 or more. The plus sign says 1 or more. And the asterisk says 0 or more. So this is 0 or 1 with a question mark, 1 or more with a plus sign, asterisk is 0 or more. All right. You can match repeating patterns. So this could be used for a phone number, for example. All right, and here's some very popular ones. I'm going to show you another site real quickly that's an ugly site, but it's a very nice site and a very worthwhile site that you might need at one time. I already showed you the regularexpressions.info. The other one is html5pattern.com. Again, ugly site, but for instance, if I want to be able to match phone numbers, phones, all right, there's the way that you can match a UK phone number, a French phone number, a United States phone number, etc. All right. And again, they've got one of the things I like so much about this book is they've got great examples. All right. One that can be really ugly is matching an email address. Okay, just so you're aware of that. All right, so you should at least be familiar with what a regular expression is, how to set up a pattern, either using a pattern or a regular expression object. What lies in the object is the regular expression literal. Flags like the /I for ignore case. There's a /G, which says show me all of them. Otherwise, it just shows you the first one by default. You now know what escape characters are. You know what a subpattern is, a pattern within a pattern, and that plus and the asterisk, etc. for the quantifiers. So they've got a program in here that does evaluation on a form. So notice there is an invalid email address, there is an invalid phone number, there is an invalid zip code, and there is an invalid year. And then they build it and they show you the JavaScript. Again, this is a really good example because it shows, in the example, it shows different patterns. There's an email pattern, there's a phone pattern. Now the phone pattern is very cut down. It expects 3 digits, a dash, 3 digits, a dash, and 4 digits. Zip code, which expects either 5 numbers or 5 numbers and a digit, 4 numbers. And date. All right. Now all this for date that's in here is it expects that it's going to be in the right format. So I don't know, for example, if I put in there February, all right, 31st, if this would catch it or not. I don't know. And that's it. So we've knocked out another chapter. Next, when we come back, we will be going over Chapter 14, which is on how to work with browser objects, cookies, and web storage. And I'll be back with that one shortly.